Video we're going to look at trigonometric identities and how we could use identities to solve equations, to solve word problems, things like that. So in this first part we're just going to look at the identity and then do an example. So we have 4 different types of identities. We have the quotient identity, the cofunction identity, the Pythagorean identity, and the odd-even identities. So the first one is just tangent of x is equal to sine over cosine. We've seen this before, and we'll see it again. The second one is the cofunction identities, or basically the phase shift. So if we shift over by pi over 2, and we have a horizontal reflection across y, we get cosine of x. And then again, that phase shift of pi over 2 to get sine of x, and a phase shift of pi over 2 with a horizontal reflection across the y-axis, we get cotangent of x. The next one is the Pythagorean identity. This follows the Pythagorean theorem. In this case, the unit circle is the distance 1, which would make that the hypotenuse. 1 squared is just going to be 1. If you remember, sine of x is usually going to give us the x distance, and the cosine of x will give us the y. So we're basically looking at x squared plus y squared equals the hypotenuse squared, or in this case, sine squared plus cosine squared equals 1. All right, the odd-even identities, because we are dealing with odd and even functions, sine being an odd function, cosine being an even function, tan being an odd function, we have the sine of negative x is equal to the negative sine of x. We have cosine of negative x equals cosine of x. So any value, like if I put cosine of negative pi over 2, we would get cosine of pi over 2. And if you think about the distance and where pi over 2 is located on the coordinate plane of the unit circle, it would be the same value. Well, probably not pi over 2. Let's go pi over 4. Both would be positive. They would be in Q1 and Q4, which are both x positive values. Tangent of negative x is equal to negative tangent of x. So this makes sine an odd function, cosine an even function, and tangent an odd function. And just to reiterate the odds and evens, if you have f of negative x, and this is equal to negative f of x, this is an odd function. And if you have f of negative x equals f of x, you have an even function. All right. Now, if you need to take a moment to write this down, please pause the video at this moment. And we are going to, after you come back, we will jump into an example. All right, so looking at this, we want to find an equivalent form. So I am given tangent, and we're going to use those identities, tangent of negative x times cosine of x. And again, what is the equivalent form? So we're going to look at different ways to look at an equivalent form of this, or some way to kind of simplify this. In some instances, something that's similar using the identities. So I'm going to start with this piece right here, tan of negative x. Well, this is going to be sine of negative x over cosine of negative x times cosine of x. Well, we're still in the same situation. Nothing has really changed except for the tangent. But remembering my identities here, this is actually equal to sine of x with a negative in front. And this one's equal to cosine of x, because these two are the odd-even identities. So now what we're looking at is sine, negative sine of x over cosine of x times cosine of x. Well, cosine of x times, or 1 over cosine of x times cosine of x is just the sine of x, so negative sine x would be my most simplified version of this, or my equivalent form of the original form. So now I can say that the tangent of negative x times cosine of x, don't know why I put that parentheses there, but I follow up by closing the parentheses, is equal to negative sine of x. All right. So let's look at another example. Let's look at 1 minus sine of x cosine of x minus pi over 2. This is a little bit more convoluted. First thing I'm going to take care of here is I'm going to factor out from this piece a negative 1. So sine of x cosine, if I factor out a negative 1, then I'm left with pi over 2 minus x. And what's the goal here? The goal here is we're slowly going to work towards the cosine of pi over 2 minus x, which equals sine of x. So this is our goal for this piece right here. Well, because this is an even function, cosine of negative x will equal cosine of x, I can now rewrite this piece as pi over 2 minus x. So 1 minus sine x times cosine pi over 2 minus x. We know that this is sine of x. I just stated it up in the blue area. So this is 1 minus sine of x, or 1 minus sine squared x. And coming from previous knowledge, I remember that sine squared x plus cosine squared x equals 1. So if I subtracted sine squared x from each side of the Pythagorean identity, we get cosine squared x equals 1 minus sine squared x. So in reality, this right here is going to be cosine squared x. Now I can safely say that 1 minus sine x cosine x minus pi over 2 is equal to cosine squared x. All right, so using these identities, these even and odd identities, the quotient identity, the Pythagorean identity, and we didn't do the, did we do? Oh yeah, we did do the cofunction identity. We could use these now to basically simplify a complex trigonometric function, and in this case a complex trigonometric expression. Alright guys, so this is the end of the video. If you have any questions or comments, always feel free to ask, and I will catch you in the next video.